Assalamualaikum and good afternoon to one and all. Today we'll study about muscle relaxation activity by using Rotarod apparatus. I am Professor Sheikh Abu Sufyan. Welcome you to AS Academy Learning Forever. At the end of this e-learning session, you are able to learn aim and objective of muscle relaxation activity, discuss principle of muscle relaxation activity by using Rotarod apparatus, and lastly, based on given data, analyze and interpret the result of bioassay. Let's see about aim and objective of this bioassay. So this bioassay, it is used to study muscle relaxation activity by using Rotarod apparatus. So here there are two things. One, it is the activity that you want to study, it is muscle relaxation activity, and how you are studying? You are studying it by using Rotarod apparatus. Let's see the requirement of bioassay. What is needed to perform this bioassay? First thing, you need the animal. So you can use the rodents like rat or mice. So based on your protocol, you can select either rat or the mice for performing this bioassay. The apparatus needed, it is the Rotarod apparatus, and drug, obviously you need to give the standard muscle relaxant drug, example the diazepam or any benzodiazepine, which having very good muscle relaxation activity in addition to their CNS inhibition or sedative action. So this is the requirement of the bioassay. Let's see the principle of muscle relaxation activity. So if you look at this image, so what this image say? So in this image, one person, he is hanging on the tip of the hill, isn't it? So he is hanging on the tip of the hill, and below this person there is a deep well. So below that person there is a deep well. So what that person will do? He know that if he lose his muscle grip, isn't it? Because he has, he is hanging or he is climbing his tip of the hill with the help of his hand, finger, right? And he has picked tightly. So what is this? This is called as muscle grip strength. So if the person who having more muscle grip strength will hang this tip of the heel for more time, whereas a person having less muscle grip strength will fall immediately. He will not able to hang for more time. Same thing will take when we are giving muscle relaxant drug. For example, person is climbing on the tip of the hill, right? He having very good muscle grip strength. So muscle grip strength, I am writing it as a MSG, that is muscle grip strength. So muscle grip strength of that person is very good. So he will hold it so that he can avoid any accident and he don't want to fall into the well, isn't it? Now the person who is climbing on this hill, if you have given the injection of sedative and hypnotics, isn't it? Now if you are given the drug like sedative and hypnotics, what sedative and hypnotics they does? So sedative and hypnotics, these are the drug which induces the sleep. The moment this drug it induces the sleep, no matter how much tightly he has picked that particular the tip of the heel, what will happen slowly? As there is inhibition of the central nervous system which is produced by sedative and hypnotics, slowly there will be decrease in muscle grip strength, right? So the moment there is decrease in a muscle grip strength, he will not able to climb this hill for more time and he will fall down into the well, isn't it? So in the same principle, we are using the instrument called as Rotarod apparatus to evaluate muscle relaxant activity of this drug. So the moment person fall, what this indicate? This indicate that sedative and hypnotic drugs has produces muscle relaxation, and since it produces the muscle relaxation, the muscle grip strength, that is MSG, it is reduced, and since MSG it is reduced, that person is not able to hold the tip of the heel for more time, isn't it? So depending upon the muscle grip strength of that particular person, he will remain for more or less time on this tip of the mountain and he will able to save himself, isn't it? So let's see about the principle of the Rotarod apparatus. So working principle of Rotarod apparatus. So first we'll see what are the different part of this instrument. So this instrument, it is called as Rotarod apparatus. it consisting of one rotating rod. Now you can see this rod is there and it having the 4 chamber, 1, 2, 3 and 4. So in each chamber you can keep the animal. So the animal cannot, every animal can, one animal cannot see the other animal. So their activity will not be interfere. So you have kept the chamber so that there is no effect of the movement of one animal on second animal. So and whatever activity you study, it is natural one. So there are 4 chambers are there. There is rotating rod. The speed of rod you can adjust, and once you adjust that speed of rod, it will be shown over here. So by using this increase or decrease key, you can adjust the speed of rotating rod. So most of the time you keep speed of rotating rod in a such a way that the one single animal can remains on rotating rod for at least 1 minute to 5 minutes, isn't it? And you select those animal who remains at least for 1 to 5 minutes. Suppose if the animal he naturally having less muscle grip strength, there are some animal who naturally having less muscle grip strength, they doesn't remain on the rod for more time. So you discard those animals should not be selected for the study. So you are selecting only those animal who remains on rotating rod of the speed that you have selected for minimum 1 minute. Okay, so you are selecting the animal who remains on rotating rod for minimum 1 minute, or depending upon the animal you are using. If you are using the rat, then rat must remains for between the 1 to 5 minutes, isn't it? So it's depend upon the protocol, that what protocol you are desiring. So minimum animal remains on rotating rod for at least 1 minute. Okay, so once you have selected such group of animal, what you can do, you can keep each animal on this rotating rod. You can start rod and you can keep each animal on this rotating rod. So now you have kept 4 animal on rotating rod. Now depending upon muscle grip strength of that animal, he will remains on the rod for more or less time, right? And the moment he loses muscle grip strength, what will happen? He will fall down. He will fall down over here, right? And whenever he fall down at this place, this counting will stop. Okay, so whenever you start this button, rotating rod will start. You are keeping the animal and this counting will start, like 1, 2, 3, 4, 5. This reading will start, isn't it? Then what you have to do, you need to keep the animal on rotating rod. When you have kept animal on rotating rod, that animal will try to remains on that particular rotating rod, and depending upon their muscle grip strength, he will fall from rotating rod, isn't it? Now this will measure the time for which animal remains in rotating rod, because the moment the animal fall down, the timer will stop. It will stop taking the reading, isn't it? So what it measure? It measure the fall down time of the animal. For how much time animals remains on rotating rod, it is measured by this Rotarod apparatus. So its work on basically on measurement of muscle grip strength. So more is the muscle grip strength, animal remains for more time, whereas less is the muscle grip strength, animal will remain for less time on rotating rod. And what you measure? You measure fall off time on rotating rod, means how much time animal take from keeping that animal on the rod and then to his falling from the rotating rod. So that time interval you measure. So when you give the drug like muscle relaxant drug, so and you measure their fall off time before and after the treatment. So before muscle relaxant drug, you can measure the fall off time. So since you already selected those animal who remains at least for 1 minute, so they will remain, maybe your reading you will get like 60 seconds, right? Then you will get reading something like 62 and 63 seconds. When you measure the muscle relaxant activity, or when you keep same animal on rotating rod, after giving the injection of muscle relaxant drug like diazepam, what will happen? This reading will reduce. This reading will come to something 3, 5, 6. Okay. So this reduced in fall off time as compared to before treatment, it indicate muscle relaxant activity of the drug. So this is about the experimental part. Now let's go to the Excel sheet and try to see how to perform this experiment. Okay. So what you need to do is, I am going to today's assignment. First go to the instruction. So what instruction I have given? Yes, so instruction are attach along is the data sheet for dummy reading of muscle relaxant activity by using Rotarod apparatus. calculate percentage decrease in fall of time. So first thing you need to calculate percentage decrease in fall of time. Draw the bar graph to interpret the pharmacological activity of given drug as discussed during lab session. Copy paste observation table and calculate in your e-journal and submit same as assignment on Google Classroom for my review and journal correction. Okay, and then I have given about the learning outcomes. So let's open this sheet. So I'm opening this sheet. So I'm opening with Google Sheet so that I can show you a calculation. Yes. So first thing that you need to do is you need to calculate dose to be administered. So what drug we are using? We are using diazepam. It is a drug belong to the category of the benzodiazepine. It is comes under the category of sedative and hypnotic drug. Okay, so it produces the sedation, and due to sedation there will be loss of muscle grip strength. Okay, so this loss of muscle grip strength, it indicates muscle relaxation activity of diazepam. So the dose of diazepam that need to be administered, it is 4 milligram per kg. So 4 kg means how much? It is 1000 gram. Okay. So the 4 milligram you have to administer to the 1000 gram. So you need to calculate the dose for 20 gram of the mice, isn't it? So first reading it is for 20 gram of the mice. So how to calculate this? You need to do the cross multiplication. So I have shown you last time also, you use the same the technique to calculate the dose to be administered to the animal. So it will be 20 multiplied by 100. Sorry, so I'm selecting once again 20 multiplied by 100 divided by 4. So whatever reading you get, okay, so it is dose to be administered. I'm sorry, there is some problem is here, there is mistake. So the dose for 1000 milligram, what is the dose? 1000 milligram dose to be administered, it is the 4. You need to calculate for 20 milligram because kg means 1000 milligram. Okay, 1000 gram. Sorry, you need to calculate for 20 gram. So we'll be doing the cross multiplication. So you will get answer 0.08 milligram. Likewise, you will be calculating for remaining on animals. Like again, I am doing this cross multiplication. 22 multiplied by 4 is the standard dose divided by 1000. So you will get dose for 22 gram of the animal, right? Likewise, you can calculate for 25 gram of the animal is equal to dose to be administered multiplied by standard dose divided by 1000. Okay, so you can calculate the dose for remaining all animals. So this is how you can calculate dose to be administered. Now next is, here I have given the reading for the fall of time, isn't it? So this is basically the reading for the fall of time after administration and before administration of the diazepam. Now you can see the before administration of the diazepam, fall of time of animal 1 it is 66, animal 2 it is 60, animal 3 it is 61, animal 4 it is 62, and animal 5th it is 63. Whereas same animal, when you give the diazepam and you measure their fall of time after 30 minutes, because diazepam at least it takes 30 minutes to show muscle relaxation activity. So when you measure this activity after 30 minutes, you can see after the treatment with the diazepam, fall of time it is decreased. It means animal doesn't remain on rotating rod for more time, isn't it? So you can take the average of this. So average, so you can apply the formula of the average. You can simply drag this, you will get average. It is coming to around 62.4. You can take average of this, simply drag it. Okay, you will get average to 6.2. So we have calculated the mean fall of time, right? So this is called as mean fall of time. So you can write this mean fall of time here. It is 62.4 before the treatment. after the treatment mean fall off time is 6.2, right? Likewise, you can also calculate percentage decrease in activity. How you will calculate percentage decrease in activity? Now this 66, it is the before treatment. So you consider this 66 as 100%, right? How much fall off time it is decreased? It is decreased to 5. So I have written it as here. Okay. Now you need to calculate percentage decrease in activity. So remember, whenever you calculate percentage decrease in activity, what you need to do is you need to subtract this cross multiplication with the 100. So what I'm doing this as 100 minus after the treatment reading multiply by 100 divided by 66. So I will get some reading, it is 92.42. Likewise, you can calculate for this reading. So equal to 100 subtracted by after the treatment reading, how much it is? 7 multiply by 100 divided by 60. Okay. So now you will get reading, it is 88.33. So there is percentage, this indicate percentage decrease in fall off time. So you can calculate for remaining all animals. Okay. So I will be calculating for one more animal so that you can remember it. So I am selecting it 100 because you are subtracting it from the 100% activity. 100 minus 8 multiply by 100 divided by 61, right? So you accordingly you will get the percentage decrease or percentage decrease in fall off time of this animal. Okay, so since there is decrease in fall off time, this indicate that the drug given it is muscle relaxant in nature. So in exam, what we are generally doing, we are giving you a dummy reading where maybe some of the reading where there is decrease in fall off time and some of the reading we are giving there is no decrease in a fall off time, and you need to identify which one is muscle relaxant drug. So how you will identify? Wherever there is fall off time, it is decrease, right? So if this reading before treatment it is more, after treatment it is less, that indicate that there is decrease in fall off time. This indicate muscle relaxant activity of the drug. Now suppose this before as well as after it is almost same, or if this is like before it is less, after it is more, what it indicate? The drug it is not a muscle relaxant in nature. So whatever test drug you have used, it is not muscle relaxant. Okay, it having some other activity. So this is how you can identify the drug with muscle relaxant activity. Now let's see how to draw the graph. So to draw the graph, you can select these two rows. So before the treatment, after the treatment, you can select it, and you can go to this icon. So what is this icon? This icon, it is insert chart. So you can go to this icon. Yes. So it has drawn one graph, but we don't want graph in this way. What we want both the reading before and after. So what you can do to get before and after reading on same graph, you unclick this. Use row 25 as header. You can unclick this and you can click switch row and column, isn't it? So I am showing you once again what was our earlier we have got this type of graph after and before. What you need to do is you can uncheck this, use row 25 as a header, and you check this box, right? The moment you check this box, you will get the graph of before and after the treatment. So you got the bar graph. So I'm just dragging it so that I will show you the further addition that we need to do, right? So now this is the graph which show the reading for after and before. I am removing this axis. I am also removing this vertical axis, okay? And I am also removing the title of the graph. I will be giving my own title. Now let's see how to give the title. So what you can do, you can go to custom option, then you can go to chart title and you can give the name of the title. What is the name of our experiment? Our name of experiment is study of muscle relaxant activity of diazepam. Okay, So now you can see the title, it's come over there. So study of muscle relaxant activity of diazepam, it's come, right? Now we need to give x-axis and we need to give the y-axis. So what you can go, I'm going again to the chart title, I'm going to horizontal axis. So horizontal axis, it is this axis. So this is the x-axis. So I can give it, because what is this, before and after? So before and after, it indicate the treatment. So before the treatment and after the treatment. Now I have typed the treatment over here, you can see the treatment come, right? Now I need to give, I need to select the y-axis. Sorry. Okay, so y-axis it is the vertical axis. So you can see now vertical axis I have selected. So this is the vertical axis, it is the y-axis. What is our y-axis? What is this 60 and what is this 6.2? So this 60 and 6.2, these are fall of time, isn't it? So this is the fall of time, and what is the unit of the time? It is for the second, because the Rotarod apparatus, it is measured in a second. So you are measure fall of time in the second, right? So you can do some addition, you need to change the color, you can do change the color, font style if you want to change, you can do that by using all this setting. So once it is done, you can copy paste this graph, this observation table in your e-journal, and you submit back for the correction. Okay, so this is all about today's experiment. So based on the graph, if you look at the graph, what information you will get at a glance? So at a glance you will come to know that before the treatment there is more fall of time, after the treatment there is less fall of time. So there is decrease in fall of time after the treatment with the diazepam. It indicate muscle relaxant activity of the diazepam. So this is how based on the data you did the calculation, you have calculated the mean fall of time, then you have drawn the graph, and based on that you did interpretation of the result, and you have interpreted that the given test drug, it is muscle relaxant in nature because it has decreases the fall of time. So this is all about today's experiment. So thanks for watching my session. For more such session, you subscribe to my channel, and if you like my session, then do remember to give me a thumbs up. Thank you.